Okay, so today we are talking about logarithmic functions and their graphs. Remember, a logarithm is an inverse function of an exponential function. So my base of my log is the base of my exponential function, and then the x and y switch places. So numbers 1 through 4 want me to solve by hand. What I'm going to do is I'm going to replace that x with the number I have. So really I have log base 2 of 32 equals an unknown number that I'm going to replace with y. And then I can rewrite this, so it can be 2 to the y power equals 32. So then 2 to what power is 32? So then my answer here is just 5. Okay. So same thing for number 2. I am going to replace that x with 1 and that f of x with y. And then I can rewrite this as 3 to the y power equals 1. So what power of 3 turns it into 1? 0. Okay. Then same thing for number 3. So I'm going to have log base 4 of 2 equals y. Okay. And then I can rewrite this as 4 to the y power equals 2. Can you easily tell what that is? You can. Why is it 1/2? Is it because 2 is half of 4? It's not because of that. So another way I could do this is I could rewrite this as 2 squared to the y power equals 2. So now they both have the same base. And if I distributed my exponents, that's 2 to the 2y equals 2. And this one is 2 to a secret 1 power. Where did you get confused at? 4 is 2 squared, right? So I just replaced that. And then I distributed my exponent, and then I wrote this one on the other side that it didn't have. So then what I can do is, since they have the same base, I can take my exponents and set those equal to each other and just solve. So I can have 2y equals 1. And then if I solve like normal, I divide both sides by 2. So my answer here is just 1/2. Questions on number 3? What? Where'd Where'd you get lost? Since they had the same base, I could just take the exponents and set them equal to each other. Okay, so number 4, same idea. I have log base 10 of 1 over 100 equals y. Then I can rewrite this as 10 to the y power equals 1 over 100. You guys know what this one is? No. So I can rewrite this right side to be a power of 10. Because it is a fraction, that means it's negative. And then 10 to what power is 100? 2. So my answer here is because I have the same base, I can take my exponents and set them equal, is negative 2. Okay, so most graphing calculators can evaluate logarithms in base 10. This is the log button on your calculator. Where did it go? Right here. It's next to 7. So what these 4 want me to do is evaluate the function log of 10 of x at each value of x. So I'm going to be doing log 10 in the calculator. So I press that log button, and then I type number 10, the number 10. And then I just press enter. This one gives me 1. That's not today. Yeah, that's going to be Thursday. Then same thing for number 9. So I'm going to do log of 1/3. So when I type that one in, I go log 1 divided by 3. Press enter. I didn't say it, but I want 3 decimal places. So negative 0.477. Okay, same thing for 2.5. So just going to press the log button and then type 2.5, which gives me 0.398. Yeah, log base 10 is your basic log. Any other base, we need to do something different, and we'll do that Thursday. Okay, number 11 is log negative 2. Whenever I have negative numbers for logarithms, I always put them in parentheses with the word. And then I'm going to go type this in. Make sure I'm using the negative from down below. And this one gives me error. So what do you think I do when it gives me error? I do not give up. I can't do it by hand. What did you say? Oh, what do I write on my paper? No. I heard it. No solution. Yes. Unless I'm like plugging into something like log of x plus like 2, it's always going to be no solution when I'm plugging in a negative. So if it's anything that's just a regular x, no solution. Thing we have are these properties of logarithms. So log, oh, that shouldn't have a Q at all. That should just be an A. It's like what we did for the first 4. So, log base A of 1, no matter what my base is, whenever it equals 0, it will always equal 0. Because anything to the 0 power is always 1. Then I have log base A of A equals 1, because A to the first power always gives me back my base. If I have log base A of A to the x, it will always equal x, because exponents and logs are inverses, so they cancel each other out. And then if I have 2 log bases, 2 of the same log bases equaling 2 different things, those 2 different things have to be the same number. And that's all easy. Okay, so number 16 wants me to solve for x. So this one is log base 2 of x equals log base 2 of 3. Just like with those exponent properties I was talking about, when they have the same base, for exponents, the exponents are set equal. So when they have the same log base, the argument, the part that comes after, is set equal. So then I just have x equals 3. Because of the bases being the same. Okay. So on number 17, I have log base 4 of 4. That was 4. I know. So my exponent on this 4 is really a 1. Whenever I have a log base in the number right after it, those are the same and they cancel out. So then I just take my exponent, which is 1. And that's my answer here. That one is, yeah, 3. Or 2, depending on, because it's a first power. Okay, number 18 wants me to simplify log base 5 of 5 to the x. This one's 3. So because my log base and my base for my exponent are the same, those cancel out, and this just simplifies to x, because it leaves me with my exponent. Okay. Last one is 7 to the log base 7 of 14. Again, the exponent and log base cancel out. So then that just leaves me with the argument, which is 14. That one is 3 again. No, because it just says simplify. It's not equaling x on this one. Okay, so last thing we're talking about is logarithms base e. Remember, e is the natural number. So this makes this the natural log. Whenever it's log base e, instead of being written that way, it's just written ln. Not I, L. So then these ones want me to evaluate ln of x for each of these. So on number 22, I'm going to be typing in ln of 2. ln is next to number 4. And then I type my 2, which gives me 0.693. So same thing for 23. I'm going to do ln of 0.3. And then I want to type that in, which gets me negative 1.204. I round because of that 9. On number 24, I'm doing ln of negative 1. So just like with normal logarithms, it also gives me no real answer here as well. So my answer here is no solution. And then for 25, because I have multiple things that are being added together, I want to write this in parentheses, so I'm going to have 1 plus the square root of 2, and then close off my parentheses when I type that in the calculator. So like this, and then I press enter, which gives me 0.881. Questions here?